Hey everybody, this is Larry. This is day 12 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, and apparently they've been doing, I don't know when I've done this, but so much that I guess in August. But yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, and this is essentially Fibonacci, right? This is a little bit of a easier dynamic programming or memorization, so I'm not going to go over it that deeply. I probably have 2 or 3 videos on this one already, so I am going to do an extra problem afterwards. One that I haven't done before anyway. But yeah, I don't, the other thing is that, Fibonacci grows at about roughly the golden, 1.616 or whatever. Is that true? To the end, right? So this, maybe you have to do the math to see if it fits in 32-bit ints, but probably. So, I mean, at least for Python, it doesn't really matter. But yeah, the recurrence is pretty straightforward. So how many steps does it take to get to some x, right? Well, it's just you go to f minus 1 plus f of x minus 2, right? And of course, you do have to do the base case. So if x is equal to 0, then you return 1. If x is less than 0, return 0, right? And that's pretty much it. And of course, you do want to cache it. So as cache is equal to force times n plus 1. Cache is equal to, I don't know, none times n plus 1. And then we just cache the thing. If has cache of x, then we return the cache. Sorry if I'm not really explaining it well this time. It is such a, I don't know, I've done it so many times that today I'm still not feeling that well. But yeah, definitely this is like almost probably the most basic. Give me the time to get it wrong because I said all that stuff. The most basic of the dynamic programmings. It's probably like one of the first things that you learn. Yeah, so I'm not going to go over it that deeply. Sorry about that. It's going to be linear time, linear space. If you really do want to, I mean, if you haven't done this problem before, the idea is that, with memorization, as I always say, is that you're given a function that always gives you the same answer. So then you just put it in cache so that you get it out later, right? And this technique called memorization is not really, strictly speaking, only tied to dynamic programming and these kind of problems. It actually has relevance in real life with respect to, that's why I call these things cache, right? So you have cache and you want to be able to reuse calculations that you've done previously, right? So that's basically the idea. But yeah, don't really have much to say about this one. The other thing that you can do, because n is less than 45, or you go to less than, or you go to 45, you can actually probably just look. Another way to do it is just have even though this is over n, the all of one solution is just have an array of 45 elements or 46 elements or whatever, and return the answer because you already know the answer for all 46 elements, and it fits on. It should be readable, or like in a readable number of lines. That's all I have with this one. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Have a good weekend.